Hello and welcome to our third video for section 3.1, and this one's all about the actual graphing of linear equations. We'll be doing that using equations and tables, and we'll get into the nitty-gritty of how that actually happens. After watching this video, I would hope that you as a student will be able to identify the x and y intercepts of a linear function and then also find those 2 points on a linear function, and we'll talk about how that works as we get into this, obviously. And once we find those intercepts, the ultimate goal here is for you to be able to graph a line on a coordinate plane, and we'll give you a couple of different methods that we'll use to do that. Before we go any further, though, we should really address that word I threw out there, intercepts. What is an intercept? We've probably heard of an interception in football, where the defensive player gets in the way of a pass intended for an offensive player and takes the ball away. Kind of works similarly. A intercept in math is a point in a graph where it crosses either of the two axes, the x-axis or the y-axis. So think of the graph as our defensive player, and it's going to intercept, or it's going to cross the line created by the x or the y-axis. Okay, it looks a little something like this. So there is our axis and our graph, and the intercepts, excuse me, are these 2 points right there. So you'll see it's the y-intercept here, where the graph crosses the y-axis, and the x-intercept here, where the graph crosses the x-axis. Those are our intercepts. Now, we'll talk a little bit right now about how to find these. It's really important. We'll start off with the x-intercept. It is oftentimes referred to by a lowercase a. You won't see that in our book too much, but I always like to give it to students because it sometimes helps to have a little abbreviation to use as we write these over and over again. And we will find the x-intercept by plugging 0 in for y. That's the most important thing here in this little green box. We find the x-intercept by plugging 0 in for y. So we'll have an equation. If you remember from our standard form video, ax plus by equals c. Well, then to find the x-intercept, we'll plug a 0 in for that y value, and then that'll help us find the x-intercept. Similarly, the y-intercept, that's referred to by a lowercase b, and this is much more common. We'll be working with the lowercase b for the y-intercept ad nauseum. You'll be sick of seeing y-intercepts by the time this is all done. But it's found in a very similar way. To find the y-intercept, we plug 0 in for x. So you'll notice that for the x-intercept, 0 goes in for y. For the y-intercept, 0 goes in for x. Okay, take some time, pause the video, ponder that for a minute. That's where a lot of students get tripped up, because it's kind of opposite of what you might think. But eventually you'll get the hang of it, and it'll be second nature. Now, these two boxes talk about how to find the x and y intercept from an equation, but what's really nice is that sometimes we can just look right at the graph. And so we will have some examples where I give you the graph and I say identify the y-intercept or find the x-intercept, or however it'll be worded in the book, and you'll have the easy job of looking at the graph and going, oh, there it is. Let's look at an example. Let's say we have an equation like y equals 2x minus 7, and you're asked to find the x-intercept, which again is found by plugging 0 in for y. So what we do, we plug 0 in for y. So we take y equals 2x minus 7, make it 0 equals 2x minus 7. Notice I'm still using parentheses to plug in my variables. It's a habit I've gotten into, and it's helped me out so far. It's not necessary, quote unquote, but it surely is helpful. Now I just have to solve this equation for x. So I'm going to add 7 to both sides and get 7 equals 2x. Then I divide both sides by 2 and I get 7 halves equals x. So my x-intercept is 7 halves, or in other words, 3.5. So if I were to plot that, I would count over 3.5 spaces on the x-axis, and that'd be my x-intercept. That's the point where my graph, this line, y equals 2x minus 7, crosses the x-axis. On a similar note, to find the y-intercept, again, I find that by plugging 0 in for x this time. So I get y equals 2 times 0 minus 7. And again, here the parentheses are really useful because they let me know, oh, this is multiplication and I'm not just throwing a 0 in there. So 2 times 0 is 0, and 0 minus 7 is negative 7. So my y-intercept for this graph is negative 7. I would go down the y-axis 7 units, and that would be the point where this graph crosses the y-intercept, or excuse me, the y-axis. Okay, part 2, graphing linear equations. So the first method that we're going to use is graphing these intercepts. We spent all this time talking about what they are. Let's put them to good use. So the first thing we're going to do is find that x-intercept A. And that would be this point here in this case. Then we would find the y-intercept, another point here. And finally, once I've got both of those points plotted, I would connect the dots. And really, it's as simple as that. Now, obviously, you have to actually find the x-intercept by plugging 0 in for y. Then you have to find the y-intercept by plugging 0 in for x. But if you can do that, that's the hard part. Plot the points, connect the dots, you've got yourself a graph. Let's look at an example. Here we have the equation 4x plus 3y equals 12, and we're going to graph it by finding the x and y intercepts for this equation. So what we'll first do is find the x-intercept, and to find the x-intercept, you'll see in my table, we're going to plug 0 in for y. Now, 0 equals y. Now our equation looks like this. 4x plus 3 times 0 equals 12. Now I've got one equation and one variable, I can solve it. So 3 times 0 is 0, and I'm left with 4x equals 12. Divide both sides by 4, I get x equals 3. 3 short steps, and I've got the first point that I'm looking for, 3, 0. Now, once I've identified that 3, 0 is my x-intercept, I plot it, count over 3 spaces on the x-axis. Now I'm ready to plug 0 in for x, and with that I can start finding my y-axis. So now I have, y-intercept. Now I have 4 times 0 plus 3y equals 12. 4 times 0 will go away, so I just have 3y equals 12. Divide both sides by 3, and I end up with y equals 4. So I will now have 0, 4 as my y-intercept. Count up 4 spaces on the y-axis. I'll get this red point here. Connect the dots, and again, like I mentioned before, that's all it takes. You find those 2 points, connect the dots, and there you have a graph for a linear equation. Now, the second method we'll talk about is using a table. And this is a little more old school, it's a little less sophisticated, I guess, but it's certainly just as effective. What you do is you select 3 to 5x values. I give the example as -2, 0, 2, but typically I'll go ahead and do 5, -2, -1, 0, 1, 2. I choose these 5 points because they usually show me everything I need to know, and they're also a really good point to start in future equations once we get to something a little more complex than linear functions. So I pick these 3 or 5 starting x values, then I'll plug them into whatever equation I've been given. That'll help me find the corresponding y values, and ultimately I will plot those ordered pairs, connect the dots, and I'll have my line. Good news, calculator will make a table for us. So a lot of students, when they decide they want to use this method, it's because they know the calculator can give us the points and they can just look at them, plot them, and move on. So keep that in mind. Again, that's something that we'll go over in class, and I'll show you guys how to do that. Now, I know we just covered a lot, but again, you can always go back and review it, get the parts that you need down again, and bring all your questions that you have to class tomorrow so that we can discuss them as a group. Thanks for watching.